Hello and welcome back to video 2 on revision for paper 1 chemistry for GCSE. As you saw in the previous video, we went through things for atomic structure and periodic table, where we covered how to do electronic configuration and how periodic table was created. We also went through different types of bonding. So in today's video, we will be looking at calculating relative formula mass. Relative formula mass is quite vital and important to many fundamental calculations that you will do at GCSE and A levels. So, what I'm going to do is show you how to do a few of them and then give you the answers to the others. This way you can then go back and do the calculations yourself to see you can get that final answer like I will show you on the video. So let's look at, just so you know, the formula of carbon dioxide is meant to be CO2. So if I pick on one that is slightly different, so let's look at sulfuric acid, which is H2SO4. For a start, you need to figure out that there are 3 different elements. So if you then go into the periodic table and look for the mass number, which is the bigger number, you will find for hydrogen is 1, sulfur is 32, and oxygen is 16. So what you then need to do is multiply this number with this number on the bottom. If there is no number on the bottom, we can put 1. So we need to do 1 times 2 plus 32 times 1 plus 16 times 4. And if you add these together, you should then get your final answer for sulfuric acid. So let's put them all in the bracket. And this way, so if I do 32, so I've got 2 plus 32 plus 16 times 4. That gives me 98. So the answer is 98. So let's have a look at a slightly different one. This time I've got Na2CO3. Again, this time you need to recognize that this is just one element, which is sodium, not 2, which a lot of kids get confused about. They think N is 1 and A is another one. No, it isn't. It's one thing. So if I then divide it again, sodium is 23, which you'll see on your periodic table, times about 2. Carbon's 1, so I'm going to do 12 times 1. So put them in brackets. And then finally, I've got 16 times 3. So if I then do 23 times 2, which gives me 46, plus 12, plus 16 times 3, 48. And if I add them up, I should get 106. So this is just a quick way of showing you how to do this calculation. So that calculation was to show you how I got 98 for the sulfuric acid, and on the bottom, the Na2CO3 is a calculation to show you how I got 106. And now, like I said, I'm going to, if I take these off, you can use this as a revision for yourself. And once you have done your revision, once you have had a go at working these out for yourself, you can work them out like I just showed you. And then what I want you to do is work these all out, and then I'm going to give you a slide that has the answers. So once you have worked them all out, you can then go back and double check that we got the right answer. So when we did the calculation, we did get 98 and we did get 106. So do take the time to work these out for yourselves and go back on this slide and double check the answers. Now, moving forward, we're going to look at something that is quite crucial to the chemistry, and that is number of moles. So working out moles, this particular one is working out moles for solid only. As you will know, there are 3 formulas for working out number of moles. So the one on this slide is only concentrating on the top is number of moles for a solid. So this one, the formula is for solid. So if you're working a number of moles in a solid, you can work out the mass. In order to do that, you can do number of moles multiplied by the relative formula mass. If you want to work out the moles, you're doing mass divided by relative formula mass, which again, something I just showed you a minute ago how to work out using value from the periodic table. And if it's relative formula mass, it's mass divided by moles. So these are the units you will use. The mass is always in grams, moles in moles, and relative formula mass is grams, moles to the power minus 1. Another key thing is to make sure if you're working in cm or dm cube, 1 dm cube is 1,000 cm cubes. You must remember that. Here is another formula for concentration. Now, concentration is equal to mass divided by volume. Now, again, if you do looking at these, look at the units because I'm dividing mass by volume. The units become grams per dm cube. So this formula here is for calculating concentration. So the top formula was to calculate number of moles in a solid only, because you have a different formula for liquid and gas. And the bottom formula here is calculating concentration. Now, if I was to work these out, these questions here, then let's go for a blank slide before I give you the answers. So if I need to work these questions out, then what you're going to do for the top two, if you write down your triangle, a number of mole is mass divided by molar mass, then you can use your triangle. So if you've been given 13 grams of Na, N is 23, so you know the mass is 13, then the molar mass is 23, you can do 13 over 23. This time you got 2 moles of lithium, again you use the triangle and put in the values. Here you're going to use a different triangle that I showed you, which was concentration is mass over volume. So you can then write down C is equal to mass over volume and then put in the numbers. So always remember what's been given to you. Always pay attention to the units and what you need to work things in and so far. So the bottom one is cm cube, but they are on the answer in dm cube. So don't forget to do the conversion. Once you've done all this, because this video is about revision, I would like you to calculate these rather than me doing them for you. I've shown you how to do them. Then what you need to do is have a go. Once you have a go, then stop the video, do the calculations for yourself, and then play the video, and you should be getting these answers. So it's really crucial that you do them for yourselves by stopping the video, posing again the questions done, and then going back and rechecking the answers to make sure you have got the right answers like I have. All the answers have been put in yellow. The next slide we're looking at is more equations for you. So far we've looked at how to use number of moles for a solid. We also looked at how to do calculation for concentration. The next triangle I'm going to introduce to you is calculating number of moles in a liquid. So this is calculating moles in liquid, and the formula is N is equal to concentration times volume. So this formula here is moles in liquid. Again, make sure you work in the right units. You can look at what's going on where and so on. The other formula that we're interested in here is moles in gas. Now, this formula only works if things are in RTP. RTP stands for room temperature and pressure. If the temperature and pressure is not RTP, then you need to use ideal gas equation, which you normally will use at A level, not GCSE. And again, you need to be careful what units these are done in. So if this is in dm cube, I have 24, but if it's cm cube, it'd be 24,000 cm cube. So be very careful of how to do that. So just a quick recap. This is moles in solid mass. So anytime you see mass or given relative formula mass and a mass, then you automatically should click in that I need to use this equation here. Anytime you have been given concentration or volume for number of moles, this is the formula. And again, if you're working in gas, you need to do volume, number of moles is volume over 24 or 24,000, depending on what units you're working in. We then looked at concentration, and then finally two more formulas that you need to remember. And this is for triple, the high and higher tier. If you're doing percentage yield, you need to do actual yield that you get in practical, divided by the one you can calculate and predict, and then times by 100 because it's a percentage. And if you're doing atom economy, it's mass of desired products divided by the relative formula mass of all your reactants times by 100. Both of these are percentages, so you must times it by 100. So I am going to stop this here because I think we have gone through quite a few formulas for you to absorb and have a go. So please do join me in the next video to look at required practicals and questions on electrolysis and so on. So I hope you can join me then. Till then, goodbye.